This video is on the Multi I Probe, an innovative current sensing measurement technique. Motors are extremely common in industrial environments. Condition monitoring for predictive maintenance is very important. The most common factors measured for this are temperature, vibration, and current, which is what this presentation will focus on. Current monitoring is increasingly used for preventative maintenance and fault diagnosis. By looking at the frequency spectrum of the current, one can characterize all sorts of different types of wear and faults. Existing current sensing technologies are most commonly Rogowski rope types or solid core ferrite types. However, they all share the same fundamental limitation. They can only measure current through a single conductor. This of course is an issue when retrofitting sensors to existing installations, and even in new installations it takes considerable planning and expense. Motor cables are usually three-phase and armoured with mild steel which is ferromagnetic, making any attempt at multi-core measurement even more challenging. Installing these sensors is therefore an involved process, necessitating skilled, trained personnel and potentially significant downtime. This Multi I Probe technology eliminates all of this, offering a sensor that can be installed by simply clamping it around the entire cable. This is a collection of technologies and techniques that can deliver multi-conductor current sensing and sensing through armoured cable. The fundamental arrangement is a ring of magnetic field sensors, either coils or magnetometers. The heart of the technology is the physics-based algorithm. With this clamp-around technology, we can determine the position of the conductors. It has inbuilt immunity to external currents. We can reproduce current waveforms and also measure harmonics. The sensor itself can be adapted to a split-core sensor, enabling it to be clamped around a conductor. In our first demonstration, this was achieved with small magnetometers, similar to the ones in your phone. Here we have a setup of the prototype with three conductors running through, each carrying an arbitrary amount of current. This plot shows the position of the conductor in the aperture. The red wire, for instance, is near the top and can be seen at approximately 20 degrees. This plot shows the measured magnitude of the current through the conductors against the angular position. The current in the red wire can be seen at the 20-degree position, which is currently equal to 2.7 amps. Here we see the Multi I Probe measuring DC current in all three conductors. Changing the polarity of the red wire results in a corresponding change in the measured current. Similarly, by increasing the current in the red conductor, we see a corresponding increase. Lastly, we can change the physical orientation of the conductors, rotating them clockwise. We can see the live output from the sensors, recognizing and tracking this change in geometry in real time. This next demonstration shows the Multi I Probe measuring three-phase current in an armoured cable. The Multi I Probe reconstitutes the individual currents in the conductors and outputs them through three analog channels measured by the oscilloscope. The fourth channel on the scope is used for a reference sensor that is attached to a single conductor, starting with the standard three-phase. Next, we add some of the 31st harmonic, shifting the reference sensor, which is the green trace, between phases, demonstrating its similarity to the Multi I Probe output. Lastly, we demonstrate the ability to measure an arbitrary waveform, in this case square and triangular waves. The Multi I Probe reconstitutes the current for each phase. Again, we are switching the reference between conductors to show its similarity. This technology can provide an easy, non-invasive way of condition monitoring for industrial equipment, and is clearly an innovative technology with numerous and valuable applications. Thank you.